In this video, we are going to very quickly explore how rolling deployments are achieved in Kubernetes, and along the way, we will also explore a manner in which we can both pause and resume rolling deployments. Let's start by checking out the state of our cluster. We have just the one deployment which has 3 replicas. This deployment is called nginx-deployment. So far, so good. Let's now go ahead and scale this particular deployment from 3 replicas to 10 replicas. For that, once again, we'll go the imperative route using kube control scale, and we'll specify that the number of replicas we want is equal to 10. Remember that in the previous video, we had rolled back our deployment, and so all of these replicas are running version 1.7.9 of nginx. We can check the status of that rollout, and this was successful. This is possible using the kube control rollout status command. If we now list out all of the pods in our cluster, we find that there are 10 of them, exactly as we would expect. 3 of them have been in existence for a couple of minutes. The remaining 7 of them have been in existence for only 36 seconds. So far, so good. Let's now go ahead and try and change the image of our deployments back from nginx 1.7.9 to 1.9.1. This is done using the kube control set image command. So this is imperative. We specify the name of the deployment as well as the new version of the image which we want in that particular deployment. This command is successful as well. The deployment image has been updated. Now, this is where it gets interesting. Because this is a rolling deployment, the pods associated with the new image are being brought up incrementally as the pods associated with the old image are being taken down. That is the whole point of a rolling update. If we now decide to pause this rolling update in the middle of the deployment, we simply can do so using the kube control rollout pause command. This will cause the rolling update deployment to be paused. Obviously, we would like to know which of the replicas are the old ones and which of them are the new. And this is very helpfully reported by the command kube control rollout status. By running this command, we can see that 3 out of 10 new replicas have been updated. We can also see that if we list all of the pods in our cluster now, we are going to get 11 results in total. 3 of these are the updated pods, so they have an age of around 40 seconds each. And what's interesting is that there are no less than 8 of the replicas of the old pods still running. This tells us that when we called pause on our rolling deployment, we had a total of 11 pods, that is 1 more than the max number of replicas, 10. And that's because one of the old replicas was about to be taken down. So you can see here that by pausing our deployment midway through, we have more pods than we had originally intended. In any case, we can now resume the rollout simply by calling kube control rollout resume. The control plane of Kubernetes will take over and start updating the new image on the replicas associated with this deployment. Let's query the status using kube control rollout status, and this time we can see in detail how the deployment waits for the rollout to finish. You can see that it counts down the number of new replicas that have been updated, and it then goes through all of the old replicas which were pending termination. Once those are all done, we can see that the updated replicas are marked as being available. And finally, at the very end of that status listing, we can see that the deployment has been successfully rolled out because all of the updated replicas are now available for client requests. Here's one last interesting diagnostic. If we were to list all of the pods in our cluster right now, we would expect to see 10 pods associated with this deployment. And what's more, we would expect 3 of those pods to have a relatively older age than the other 7. Why? That's because recall that we had paused our deployment when it had updated 3 out of 10 of the new replicas. And indeed, when we call kube control get pods, this is exactly the case. We have 3 pods out of 10 which have an age of exactly 1 minute. The other 7 pods have ages varying between 19 and 36 seconds. We have successfully demonstrated rolling deployments as well as the pause and resume of a deployment in the midst of a rolling update.